Hi guys, my name is G and welcome to this lecture on the GaussDB security architecture. In today's digital age, the security of a database system is of paramount importance. As a highly secure and reliable database system, GaussDB employs a comprehensive multi-layered security protection framework to provide all-around protections for user data. In GaussDB, multiple measures are used to maintain database security. These measures can be summarized into three aspects: permission management, security policy, and system audit. Through today's lecture, you are able to understand the overall security architecture and security design principles of GaussDB, know how to set up a secure database connection and maintain relevant configurations, understand the concept between users and roles, know the user permission management model, grant and revoke system permissions and object permissions as required, understand auditing and know well in setting, querying, and managing audit log. Learn high-level security features and security policies of database, including row-level security control, dynamic data masking, and unified audit policies. Be familiar with data encryption and decryption functions to protect data privacy. Preliminarily understand the fully encrypted database. Next, let's introduce course contents in chapters. This is a complete database security architecture. We hope to build an architecture with a defense in-depth system to ensure data security. Firstly, an impregnable security awareness framework is established through abnormal behavior detection, dynamic threat detection, and other methods, preventing external attacks from breaching the system. Secondly, a trustworthy connection is built, where all links undergo trust authentications before accessing the database system, making it impenetrable to illegal access attempts. Furthermore, access control are implemented to avoid privilege escalation, ensure that data remains unextractable. Even if data is successfully extracted, the data masking and encryption techniques render the information indecipherable to attackers. After data is persisted, tamper-proof design prevents any modification, even by high-privileged users, maintaining the immutability of stored data. Additionally, all tasks executed during system operation are comprehensively logged and audited, providing irrefutable record that cannot be repudiated. Finally, a complete authentication and evaluation system instills trustworthiness in user, assuring the integrity and the reliability of a product. What we see here shows the security capabilities of GaussDB. For example, the legal database mechanism formerly introduced in GaussDB v5, Kerberos authentication for access validation, role-based permission control model, role-level access control model, dynamic data masking for data privacy protection, virus encryption mechanism for data confidentiality, security network protocols like TLS and HTTPS ensuring communication security. All these capabilities build a full-link security process from login management, access control, data protection, audit trail, and data display. Ending the overall security outline of GaussDB, let's talk about some important features in detail. The first part is access control and login management. The GaussDB access control rules are manifested in the gshba-conf configuration file, where each lines represent an authentication rules with higher priority given to rules listed earlier. Specifically, the file includes type, specify the connection type to the database, supporting local for local connection, host for accepting local or remote sockets, as well as configurations for accepting only SSL encrypted or non-SSL connections. Database and users are self-explanatory, referring to the database being connected to and the user account used for the connection respectively. Multiple objects are comma separated, with all matching everything. Address declares the matching address supporting both IPv4 and IPv6. Methods specify the authentication method used during the connection, supporting SHA-256, cert for certificate authentication, reject for blacklisting, etc. And GSHBAconf file can be configured using the GSGUC tool. Here is an example. This line allows both local and remote from a specific IP using the user account with SHA-256 authentication methods to connect to the Postgres database. After explaining how to configure access control rules, let's look at the validation performed during the login process. First are the various configurations in the GSHBAconf we just discussed, followed by verifying the authenticated user exists in the database or it is logged out. Password validation is based on the RFC 5802 protocol, and a specific process can be seen in the diagram on the right. Store key and server key are used for forward and reverse authentication respectively. The client signature is computed and compared with the client proof sent by the client to recover the client key. The derived values is then compared to the stored key, and if equal, client authentication succeeds. Server authentication is similar, where the server signature is compared with the local signature to complete the verification. Additionally, the following validation are performed. In database check, we verify the correctness of the target database being connected to. For user validity period, we check if the user validity period is still alive. The validity period can be configured using the valid begin and valid until keywords when creating a role, with no restriction by default. Maximum connection limit, validating against the max connection parameter, which restrict creating new connections once the maximum limit is reached. Regarding password policies, GaussDB support automatically locking and unlocking of the database. If the password is entered incorrectly more times than the failed login attempts param limit, the system will automatically lock the user account. The lock duration can be configured through the password lock time parameter, after which the account is automatically unlocked. Administrator can also manually lock or unlock user account using specific syntax, alter user lock and alter user unlock. The password stored encryption method is configured through the password encryption type parameter, with SHA-256 encryption as the default. MD5 also accepted but not recommended for the security consideration. And GaussDB support configuring password complexity validation to impose restrictions on password lengths, character types, and more through the password policy configuration. It also supports checking against the weak password dictionary to prevent the use of weak passwords. Additionally, you can configure the number of days before a password can be reused and set a password validity period to enhance password security and trustworthiness. This image shows the different ways a client can connect to the database and their corresponding behaviors. It's important to note is trust connection, which refers to a type of connection that GaussDB accepts unconditionally without requiring a password. This is a high-risk connection method for security reasons. GaussDB currently only allows super users to log in locally use the trust method, while remote connections are prohibited. The following is a simple example of connecting to a database using GSQL client. Start with GSQL, of course. -D GaussDB means we are going to connect to a database named GaussDB. -U indicate username and -W indicate the password. Then -H shows the server IP address and as well -P shows the server port. In addition to supporting the GSQL client, GaussDB also supports connecting to the database using clients such as the JDBC or ODBC. For specific usage, please refer to the corresponding user manuals. The previous page covered the general ways a client can connect to the server. To further enhance security, especially for remote access scenarios where data stream could be intercepted or reply attack could occur, we need to adopt SSL secure connections. After the cluster is installed, the server certificate, private key, and the root certificate are all configured by default. User only need to configure the relevant parameters on client side. For the GSQL client, you need to configure the PGSSL mode parameter. The default value is preferred, which means it will attempt an SSL connection first, and if that fails, it will try a non-SSL connection. For JDBC client, you need to configure the SSL mode. It is recommended to set to preferred or required, where required means we only attempt SSL connections. From a security perspective, it is recommended to use two-way authentications, in which case the client's PG SSL mode variable should be set to verify -CA. However, if the database itself is in a secure environment and the business scenario involves high concurrency and low latency requirements, one-way authentications mode is a better choice. Next, let's move on to the permission management model. For GaussDB, the concept of users and roles are similar. A role can be viewed as a collection of one or more users. Users are primarily used to connect to the database and execute SQL statements, while roles focus on organizing and managing permissions. Users can be granted roles, and when the role's permissions are modified, the user's permissions is also synchronously modified. A single user can be granted multiple different roles permissions as required. This statement allows us to manage roles. Create statement for user or roles creation. Option clause is on the right. Take some options. For example, sysadmin determine whether a new role is the system administrator, non-sysadmin by default. The following several parameters are the same. Monitor admin, operator admin, etc. And createDB and createRole indicate whether a new user has the privilege to create a database or user. Alter statement and drop statement are used to modify or remove a user. Grant and revoke statement used to manage the specific privilege from and between users. As this example, we create two users, then we grant a login privilege to row 1. Here we check their information by select the PG auth ID or PG rows. Check the third column. Row 1 is true and row 2 is false. We set it just now. And then we assign row 1 to row 2 with grant row 1 to row 2 statement. As a result, row 2 inherit the permissions of row 1. We'll PG auth members to obtain the row relationship. At last, we remove these two users by drop them. And after briefly introducing roles and users, let's look at what permissions they can obtain. First is the system permissions. System permissions, also called the user attribute, refers to the permissions specified by the system for a user to use in the database, such as connecting to a database like login, creating a database, createDB, and creating a user, create role. We just mentioned some of them in the option clause when creating a user. And with a simple example, create user 1 with a create role permission, and then use alter statement to grant monitor administrator and to row 1 and revoke a createDB. Also, we can check the PGOS ID to review our settings. This diagram shows the default hierarchy of a system privilege in GaussDB. Higher level privileges automatically have all the capabilities of lower ones. At the very top is the initial user with full super user powers. Right under that is the sysadmin privilege. Sysadmin has some commonly used sub-privileges under it, like create role, audit admin, createDB, and so on. Additionally, GaussDB offers the options of a separation of duties for enhanced control and security. Under these three role separation models, the system administrator role is no longer granted the privilege to create, modify, or delete user account and roles. Furthermore, the system administrator does not retain the ability to view or maintain database audit logs. Through this reasonable segregation of a privilege, the overall security postures of the database can be significantly enhanced. Having covered the system privilege hierarchy, let us now examine object-level privilege management, which represents another critical dimension of access control within GaussDB. GaussDB can be regarded as a whole of many objects, including tables, functions, table spaces, and even columns. All operations on these objects can be classified into DDL, data definition language, and DML, data manipulation language. DDL permission include the create, drop, and alter. DML permissions include insert, delete, and update, and so on. This diagram illustrates the various object privilege types currently supported in GaussDB, as well as their relationships. In real-world business scenario, we suggest to follow the principles of least privilege by granting only the minimum required permissions to each role or user. All operators should be assigned the bare minimum set of privileges necessary to fulfill their designed responsibilities. In example 1, we grant select access of a table TBL to user 1. After the access is granted, user 1 can perform select query on TBL. Besides, for we use a with option clause, user 1 can also grant such access to other users. And in example 2, we grant alter and drop access to user 1, but without option clause, user 1 cannot grant these two access to any further. Revoke access by using revoke statement. After this statement, user 1 will get an error message permission denied for relation TBL while performing a select query. And we can query PG class for table object acknowledgement details and the PG proc for PL SQL or functions. Look at this example. We query real ACL, which means the relation acknowledgement field on the PG class for table TBL. Here we got is a formatted string. Each group consists of three parts: authorizer, permission, and the grantee. Table TBL is created by OMM so that OMM has all privileges for it. User 1 got a select access from OMM and he can reauthorize to other user. User 2 has a select access as well, and he cannot grant it to others. Beyond the object level privileges, GaussDB further supports the granular row-level access control mechanism. This allows for constraining users' ability to view, update, or delete data to specific roles meeting defined criteria. Row-level security policies provide a fine-grained method to filter data accesses based on row content. By crafting appropriate policy expression, database administrator can ensure that users only receive results set limited to the row they are authorized for based on the contextual attributes, data values, or other rules. We can have an example. Here is a doctor-patient model. Mary and Tom are doctors and they have several patients. All this information are stored in one table so that they can query each other's patient. We can create a row-level security policies to restrict their access. By setting doctors equals to current user and then enable RLS for this table, doctors can only access their own patients when performing select query without specify a where clause. So far, we have essentially covered the various privilege type in GaussDB. In practice, privilege management must strictly follow the principle of a least privilege, only grant user or roles the bare minimum permissions required to accomplish specific tasks, avoiding indiscriminate assign of full privileges. Additionally, permissions should be time-bound and revoked promptly when no longer needed. After talking about authority, let's look at audit. Currently, GaussDB supports traditional audit and unified audit. GaussDB provides an audit setting called audit enable for system-level auditing control, supporting dynamic loading. In addition, 11 audit configurations are provided for detailed settings such as login and logout audit, and authorized access audit, and authorization audit, and etc. The preceding parameters can be configured use the GUC tools as well. Audit resources policy determines the audit log cleanup policies. When set to on, it prioritizes disk space and log cleanup the governed by the values of audit space limit. When set to off, it prioritizes time, with log retention determined by the value of audit file remain time in days. Within the specified time window, logs accumulate and checked. Once beyond that window, log cleanup in the subject to the store capacity limit. To view and delete audit logs, you must have the audit admin system permission. Using function pgQueryAudit to query audit logs and the pgDeleteAudit to do deletion. Mention here, audit log deletion here is only a logical deletion instead of a physical deletion. All audit logs files will still remain on the disk. In a high concurrency server scenarios, the traditional audit mechanism generate a large number of logs and update the logs very frequently, which is inconvenient for audit administrator to manage. In addition, the traditional audit mechanism cannot distinguish information such as access source and access objects, and the audit logs cannot support target management. GaussDB provides customized audit policies to audit tables for specific behaviors that you care about by using create audit policy statement. This statement has a privilege audit clause for DDL and access audit clause for DML. After that, an option filter group clause to filter the target. The target of an audit policy can be a database or a resource label, which can be regarded as a set of tables or columns. Here is also an example. Firstly, we create a table for audit and the resource label for it. And then we create audit policies ADT1 for create or ADT2 for select. They are all global audit policy. Then we create audit policy ADT3 for create on label we created just now and filter on some rows, which means we only care about create statement by Dave audit and Bob audit on the audit label 0. Then here is a more complicated policies ADT4 for select and insert on label ADT label 0 by dev audit and Bob audit, whose client is physical or GSQL and IP address are these two addresses. Besides, for creation, we can also manage the policy with alter and drop statement. Finally, let's look at the data encryption mechanism. Firstly is dynamic data masking. Generally, system permissions control mechanism cannot deal with the access to privacy data, so we introduce masking method to anonymize the data in real time to meet the principles of a least privilege. Laws and regulations in different countries or regions, such as the GDPR, General Data Protection Regulations, stipulate that different users have different object access rights when managing data. The syntax is a create masking policy. Masking functions could be mask all, random masking, credit card masking, basic email masking, full email masking, shuffle masking, all digit masking, and so on. As well, we can apply the masking functions on certain resource label and filter the target by filter clause. Also, with an example, we have a table named the user info table, which contain UID, name, phone number, email, and credit card. Most of them are privacy information, so we'd better restrict the data output. What we can do is to create resource label for each column and apply masking policies for each label. All digit masking for phone number, basic email masking for email, credit card masking for credit card info. As a result, we can see when we select again, phone number is replaced by all zeros, Email address before @ is replaced by X, and credit card info are also only the last 4 digits as a distinction. If you have a specific data need to be masked, GaussDB masking functions support customization using regular expressions. And for data encryption, GaussDB provide GS encrypt AES-128 functions to encrypt the message with a given key. Also, GS decrypt AES-128 can be used to decrypt the data. Currently, the encryption and decryption API support the AES-128 CBC algorithm and the SM algorithm, which is as known as the Chinese standard encryption algorithm. Then comes with TDE, transparent data encryption, which means data stored in plain text in the memory. When database do flushing, the encryption functions interface is used to encrypt the data into ciphertext and write to the disk. Decryption will be done while the page is loading into the memory. Now GaussDB support cluster-level TDE and table-level TDE with AES and SML algorithm. Key management service is required to protect the keys. You can visit the public cloud DW for further details. And at last, let's take a brief look at the concept of a fully encrypted database. The key ideas are all data is encrypted on the client side and kept in ciphertext form through the transmission, storage, and the calculation. Only the user control the decryption key. The approach enables separation of data ownership and data management, resolving potential privacy leakage issues after data is moving to the cloud, as well as the trust concern regarding the third-party cloud service providers. Transparent to applications through the client parsing, so we can implement a smooth service migration with fully encrypted database. And so as a summary, in this course, we first introduce overall security architectures of GaussDB and authenticated for login and the connection. In user permission management, we emphasize the minimum permission principles and introduce RLS for fine-grained object permissions. In the third part, we talk about two kinds of audit. Unified audit allows you create a customized audit behavior. At last, we discussed privacy protections using data masking and data encryption. And that's all for today's lecture. Hope you guys all enjoy the content and thanks for your concentration.